Hello and welcome back. So in this video, Lee said he was going to be visiting the GameManager again.
Yeah. It's like going, this guy right here.
Yeah, that
It's going
one.
to be a little bit more advanced. But hey, you know what we should do first? Let's make config.load settings in here. Oh, it's right there now.
Yeah, what do you know?
Hey, we're done with GameManager.
Who would have ever thought that we would have possibly wanted to test out the TerrainMeshBuilder in the last video? That's just crazy.
Well, I was trying to, throw a cookie to our viewers and go, hey, look at this. Isn't it awesome? And once again, I end up looking like a fool, but whatever. It's all good. All right, so let's go ahead and we're going to add some more stuff to it. Mostly, we're going to make an instance called GameManager, just so we have an easy way to reference this. And then we're going to come down here and we're going to say instance equals this inside of start. And then we're going to load our settings from config. Oh yeah, we've already done that. Awesome, great. We don't have to do it anymore. Now, the other thing that I would like to do is to take our, well, hold on, before I do that, let's go into TerrainMeshBuilder, and I'm going to take this train generator from here, and I'm going to steal it. So I'm going to bring it from here, put it in the GameManager, and I'm going to put it, let's say up here. So we'll make it a private static read-only train generator. And then we need to go down here where we initialize it and pull it from here. And then move that back into the GameManager over here. So we can set that up.
No, you can't.
Sure I can. Watch me. Look at how awesome that was. Can too. There, let me change the name too. So it's
Well, you could have just killed out read only, but
well, I could have, but I also want to make this public. See, like that. So I'm trying to follow my notes, and let's see from here. So now I've got that, and that allows me to go into. Oh, how did I do that? Oh no, I did it completely backwards. That was nice of me. But right, TerrainMeshBuilder from here. Let's go to. Whoops. GameManager.instance dot train generator capital T train generator get smooth height. Okay, now we only got one train generator. All right, and back to the GameManager. All right, now I don't want this guy anymore. A source of all my misery, and we also don't need updates. So I'm going to get rid of this too. Now I'm going to make a var. This is going to be called start time. And I'm going to put in some of our timing information just so we can compare and contrast and play around with some stuff if we choose to. This is basically what we did when we're testing all this to compare patch size creation and all that real fun stuff.
Hey, Lee, let me get you to hang on for 1 second, okay?
Uh-huh.
Okay, we're resuming, and that's my apologies. That's the fun of recording all the time, is from time to time we do have emergencies that pop up that need to be dealt with, and that was one of them. Okay, Lee, let's go ahead and continue.
All right, as I was saying, we're basically now putting in some functionality to track elapsed time for the amount of time we spent creating these patches. I initially put this in for debug information or testing purposes when we were trying to test different patch sizes and how long it's taking to create, how long it takes to create with a mesh collider, how long without. But I'm going to put this in because it's kind of fun to play with, or just to be able to look and see how long it took to create X number of patches. So when you're planning out a large a batch of patches to be created, you can kind of guesstimate how long that's going to take. So just a start time, then we're going to take our debug log, call it elapsed time, and to get our elapsed time is datetime.now minus start time. So that will give us our elapsed time of everything that happens between our start time and this debug.log. So everything else goes in between these two that you want to track. In our case, we want to create some patches. So I'm going to set up a var called size, and to keep things small, I'll use a size of 1. Use a couple of nested loops. So for I, instead of I want to use z. This will be size, and this will be size less than or equal to, and we're going to start off at negative size. So basically, just like before when we wanted to make an array or an array of patches, we're just going to do the same thing again. So this will be x. And then inside of here, we'll go ahead and make a position variable. So var position equals new vector 3. We'll use x comma 0 comma z for our position. And I'm setting up this as a variable for now because there's going to be some more stuff that we're going to need with it later on. But once we have it, we'll just call TerrainMeshBuilder, and it needs a vector 3, so we pass in position. Go ahead and build that out, make sure there's no errors. And if I run it, we should see a 3x3 grid of patches with an elapsed time. And there's our patches. So we've got 1, 2, 3. So by 3. So 3x3 array of patches. Now,
And elapsed time?
I don't know, something like 2.7 seconds.
Okay.
So hold on, that's hours, minutes? Yeah, that's seconds. So 2.764 seconds to create these. So you can start to see why we didn't want to use these patches in real time. So let's say I'm going to open up my handy dandy calculator, and let's open up a copy of Notepad and resize Notepad. And I can get rid of our unit conversions. So let's say we've got a patch size of 51. Patch size of 51 took 2.76 seconds. So 2.76. Divide that by 9. So we're about 0.3 seconds per patch to create that. Now, if I go ahead and clear this, stop this, jump back over into code, let's do a patch size of the largest that we can create, which is 250. Technically, we could do 255, I think, without blowing. 256 blows up.
Make sure to use an odd number for the patch vertex count. There you go.
Yeah, hey, what do you know? So let's make 251. Hey, I never read these notes.
I understand.
What's the point? But this is basically a space of 250, so it's 251 vertices with the edge. These are absolutely monstrous patches, and I wish we could have used them. I really, really do. But
yeah, but the collider killed us.
well, not even the collider. Before we got to the collider with these patch sizes.
No, I thought from the asset
well, the collider
bundles.
kills us. Well, from the asset bundle, the speed load, we can't do 250 period from the asset bundle because we can't import in the FBX importer more than 65.
Oh, that's right. That's right. We had to drop down to what, 151 or something.
Yeah, 151 was the first size that made sense.
Yeah,
that was easy, the tile that we could use.
But even then, the collider killed us.
Yep. Well, patch creation size was too long, and collider was even worse. So, as you can see, we're still making patches right now. And we're still making them.
Patch creation was too long?
Yeah.
From streaming? That's what I'm just referring
No.
to the end product.
Oh, okay.
And with
You're
the
talking
end
at the
product,
very end, yeah.
the collider just made
The
it
collider
prohibitive.
wouldn't make it possible.
Exactly.
So, yeah, and we're still baking.
Oh yeah. Oh yeah. It's
But,
huge.
I mean,
But look at the
1
size
minute,
of
6 seconds. But look at how much train we get with just 9 patches.
pretty incredible.
So you're talking each one of these patches is 1 square kilometer. So this is 9 kilometers of terrain, or 9 square kilometers of terrain, and it takes a minute to create, or a minute and 6 seconds. So if we open up our calculator, clear this out. So now we're looking at 66.5 seconds. Divide that by 9, 7.4 seconds each. So notepad. So 251 equals 7.4 seconds to create each one. So both of these, the 51 just doesn't work real time, but not too bad. But once you add the collider to it and realize that adding a collider adds about 7 seconds to it. So, and we can demonstrate that too. It's not that hard. So we know 251 is completely out. Even before we get to the mesh, it takes too long to create. So, and even if we were baking all this stuff out ahead of time, like we are now, we still couldn't use a patch size of 251 or even 200, and we have to get down, I think it was like 165 is the highest we can use before we exceed the 65,000 triangle bogus limit that is on the FBX importer. We're supposed to have a limit of 65,000 vertices, not 65,000 triangles, but it blows up anyways in the importer. So we had to look at a size of 151 and down. But let's say we already discussed that 100 and 151 is too large, and I don't want to spend a lot of time generating those. But I do want to go ahead and go back to a 51 patch. So we'll use a patch size of 51. I'm going to go into our TerrainMeshBuilder, and inside of here, I'm going to go ahead and just add the collider. So let's go to, after we've got our mesh set up here, let's just go ahead and do mesh object dot add component, and we'll add a mesh collider. And so this is just adding the mesh collider. And we've already seen that it should take about 0.3 seconds without the mesh collider for 9, or with 9 patches, about 0.3 seconds each. So with adding a mesh, if I clear this and I run it again, the first roughly 5 seconds is the train generator initializing itself. And then we come back up. We've jumped up to 2.7. Do these have meshes on them? Mesh collider train mesh. So 2.7 seconds. So notepad, and here with the smaller patches, so we've got 2.7 divided by, 2.7 divided by 9. 0.3 seconds. So it's about the same with or without a mesh collider.
If you recall, that's why we decided to go with 51 at the end of the day, is because it was just a fraction of a second, and we could afford that with the lazy load.
Yep, and if is it train or ND?
Not even so much lazy load, just load as required.
Right. No, it was 51. It takes 0.05 of a second
for
to
the
create
collider.
the constructor.
The
0.2
constructor?
second, or the
collider.
Collider, yeah. So 0.05 of a second for that collider. So we don't see almost nothing, or we see almost nothing. 0.2 of a second for a 101. A 251 patch with a collider, 7 seconds. So it was just completely out.
Yep.
But 51 was our first point. We tried the 101, and it almost worked. It was almost enough that we could make it playable, but it just wasn't the same. So that's why we opted with 51. And then with the what's fun is if we go kill this, and one of the reasons that we chose the size that we did for those people that have standard, which was a patch size of 9. And we run this. So first 5 seconds, terrain generator warming up. And then there's our meshes. So that's hours, minutes, seconds. So 1/10 of a second to create all 9 patches. Of course, they're itty bitty.
Yeah.
But this is with a collider.
Mm-hmm.
So 9 patches, 1/10 of a second. And this is why this is the patch size that we chose for the editor and for people who are using the standard, because you can load a large amount of these very, very quickly.
That's right.
So that's where all those number crunching came into play. So you can see it from that point of view. So let's go back into our code. Let's set ourselves back up to 51. Let's go into our mesh builder because we don't need the collider. And even if it's only 5/100ths of a second, those 5/100ths of a second add up when you start doing thousands of these things. So we've got that. We've got our no, that's terrain generator. I can close this. Don't need it. Config. Close this. Don't need it. Leave this one up. Leave this one up. And for now, that's going to be it for the TerrainManager. I do recommend, if you get to this point and you haven't played with different patch counts or the vertex counts and the vertex spacing, play with them. Experiment with your machine. The numbers you get will probably most definitely vary greatly based off of mine, because like I said, I've got a 4 or 5 year old machine. These numbers would have been insanely small on Jason's machine. But then again, not everybody's running dual hexen core machines, so it's not really a fair way of judging the performance of a game based off of his machine.
Agreed.
So, but play with it on your own. Your mileage will vary, and figure out what works best on your machine.
All right, and with that, that's going to wrap up this video. So in the next, we're going to get into our first exporting to the OBJ exporter.
Oh yeah, that thing.
Oh yeah.
Yeah. Did I mention that if you don't like string manipulation, you're probably going to be hating a good bit of this series?
Come on.
It's gonna, but you know, when you make it through it, you're going to be an expert with string manipulation. We're going to be doing a whole lot of it.
All right.
Starting in the next video.
Well, with that, that is going to wrap up this video. Thanks a lot, everyone.